Hi everyone, so this is another MATHCOUNTS problem. So this is also a team run number 10, okay, on a state test. So we are given a square, side length is 1, okay, which is this guy. And the center of the square is cent A on a circle with O is the radius. I mean, O is the center as well. Okay, so we have a circle right here. The center is O, and then we have a square, center is A. And the radius is 1, the side length of the square is also 1, and the radius is perpendicular to the side of the square. Okay. And what is the area of the shaded region? Okay, so the question is kind of clear for sure, but the area that we are trying to find is not really nicer. So I usually recommend my students to connect the center point to some intersections, which usually helps whenever you have some sort of intersection. So in this case, I have this my center. I have this corner of the vertex of the square, but there is a really nice intersection of this square and the circle. Since we are trying to find the area in between those two, so maybe it's helpful to connect these 2 points, which will give us a radius as well, which is also 1. But if I want to do the same thing with the other side, which is okay, so I can actually do that. But it doesn't really help, at least for now. But I can find the area of the square, I can find the area of the rectangle and stuff like that. So which is why maybe I can take this shaded region and split into two regions like this, because I may find the area of the rectangle easily. And then if I find the area of this piece as well, which is a segment, okay, so we can just combine those. But to do so, we need to find this length of the square, I would say the rectangle, and then I need to know this guy as well, which is, I don't know that yet. I know this side is 1, so let's actually write that as well. So this is 1, and then this is also 1, this is also 1. Actually, there is really not something going on right here. This is 1, and that is why this is also 1, and this was my radius, that's 1, this is also 1. That is a equilateral triangle. So if that's the case, I can say this guy will be 30 degrees, and this is also 30 degrees, and this is 60, and this is 60. This is good because this is going to help us with the 30, 60, 90. So let me draw that one more time so we can actually see how that looks like. So we have a 30, 60, 90. Again, if you do not remember the features of the 30, 60, 90, it's good to remind right now one more time. So smaller leg is, let's say, x, and the hypotenuse will be twice as big. The other leg will be √3 times of the smaller one. So based on this, we know this was 1, so this piece is 1/2 in our case. Okay, so let me kind of draw this one more time. So this is my OA. Okay, so this is my center of the circle. This is the A, and let's go, this is B. And this is 1/2, and then this is 30 degrees. If this is 1/2, that means this was already 1 because that's radius. And this leg will be the smaller leg times √3, which is going to be 1/2 times √3, which is √3/2. Again, this is the distance between O to this point. And I do know this was my center of the square, which means if I want to extend this guy right here, so this piece and this piece has to be the same. So that will be 1/2, and the other piece right here is going to be 1/2 as well. So let me name this as T. So the AT is also 1/2. But we want to find this piece. I don't know that piece yet, so let me call this point as maybe K. So AT is 1/2, but at the same time, I do know OK, which is actually this was an A, so this was K. Okay, OK was √3/2, and I do know this point T to distance to A, so this was 1/2. The other part OT is also 1/2, because the T just right in the middle, since this is my Actually, OT is not 1/2. OT is what's remaining from the 1. So I do know AT is 1/2. Okay, so let me take this guy. AT is 1/2 because A is right in the middle of the square. And I do know OK. So let me write right here. OK is gonna be √3/2. Okay, so now I do know this piece OT. Yeah, actually it was 1/2 because the distance between OA was 1, TA is 1/2. So the other part OT has to be 1/2 as well. So to find the TK, okay, so TK, which is this side, maybe I should color differently. So this piece right here is my TK, right? So that would be OK minus OT. So OK minus OT. OK is √3/2. And OT is 1/2. So which is why this is the difference between these two numbers. And that is also same as this part, which is this one side of this rectangle. And the other side of that rectangle was just 1. So if I want to find this region, so let me shade this region in green. So this region right here is gonna be the green area will be this leg is, this side is this number. So √3/2 minus 1/2. And the other side, which is this side of the square, is 1. So that doesn't make any difference when you multiply by 1. So now I need to know the area of this segment right here. So this piece, right? So this is also not too challenging because I see something going on. So let me kind of do that separately as well. So if I wanna draw something like this. Okay, so we have a equilateral triangle right there. So it doesn't really look like nicer, but let me try a bit better. So we have something like this, right? And then we know this is O, this is B. So I don't know, let's say this is C. And I do have circular piece. And then I just need to know this region because we know we got this green area. If I find this guy, this region as well, so I can combine those two to get my shaded region. Okay, so the angle at O was 60 degrees because that's 30. So this is a sector, right? So that the blue region, I will say, region is equal to area of this sector, which is 160 out of like 360, which is 1/6 of the full circle area. So area of the circle is pi times radius square. And I do know these guys is 1. So that is pi times 1 square is area of the full circle. But this region is 1/6. So that will 1/6 over like 1/6 pi. But that is this sector area, right? But if I need to find this blue like shaded region right here, I need to subtract area of this equilateral triangle. So this is also 1. And if you do remember the area of the equilateral triangle, that is maybe good to remind as well, s squared times √3/4. And that is the area of the equilateral triangle. And if you don't remember this one, you can always drop the altitude right there. And that will be 1/2, that will be 1/2. And you can use 30, 60, 90 or just Pythagorean to find the height of this triangle. And you can go from there to get the area of this triangle. But it's good to remember this guy as well. So the side is 1. So 1 squared times √3/4. The blue region will be pi over 6 minus √3/4. Okay, so this is my blue region, which is like this piece. And then we already got the green area like this. So all I need to do is just add these two guys together, okay? So that will be our final answer. So √3/2 minus 1/2 plus pi over 6 minus √3/4. Since this was a team run, so you can just plug those numbers in your calculator and you're looking for the nearest 100, right? So that will be approximately 0.46. Okay, so that is my final answer. So this was a challenging question, but a couple of things from this maybe problem that we need to think about it just to get better. As you see, we use the 36 and 90 for sure. And then we use the area of the quadratic triangle, and then we use the segments, and that is something we need to know. And also, one of the maybe most important approaches about the some funky regions, you need to split the region into some regions that you can actually handle it. So in this case, I split it like this because I can handle the rectangle, I can handle this main region. So that is a good skill as well. And also, as I start this like question, I said, whenever you are dealing with a circle, like go ahead and find your center and connect with some intersections, which was this point and this point. So that usually gives you some great regions to do your like kind of work. Okay. So I hope that makes sense and it was clear. And I'll see you in the next video.